Mean value theorem for integrals. The mean value theorem for derivatives indicated the value of c at which the slope was equal to the average slope. The mean value theorem for integrals will indicate at which value of c the function reaches the average value. Imagine we had already calculated the average value for our function and found it to be around 30 miles per hour. The mean value theorem for integrals states there is at least one point, which we'll label c, where the function must take on its average value. What does that mean in the example above? Although the car was not traveling at 30 miles per hour the entire trip, there must have been at least one point on that trip where it was traveling at that speed. In this case, by observing the graph, there will be 2 points at which this occurs. And as we stretch along here, there's a point here at 30 miles per hour and a second point where it reached 30 miles per hour. The mean value theorem states the following. If f of x is a continuous function on the closed interval a to b, then at some point, we'll label c, there exists f of c, which is equal to 1 over b minus a times the integral from a to b of f of x dx. Now it's important to note that c has to be between a and b in that interval. So this means that at some point, we'll call c, that average value is equal to the function at c. For an example of the mean value theorem for integrals, let's find the value or values of c that satisfy the mean value theorem for integrals, given that f of x is equal to negative x squared minus 8x minus 17 on the closed interval of -6 to -3. So at this point, we set up the formulas to find the average value. Now, you may recall from earlier lessons that the average value is 1 over b minus a, and in this case, a and b are -6 and -3. So we have 1 over -3 minus -6 times the integral from -6 to -3 of our function. Integrating the function, the integral of negative x squared is -1/3 x cubed. The integral of minus 8x is minus 4x squared, and the integral of 17 is 17x, and they're going to be evaluated from -6 to -3. Doing that work, we find out that the average value is equal to -2. So at this point, we set up the mean value theorem for integrals by setting the solution equal to f of c and solve. So let me point out that our mean average value, was equal to -2. And what I do up here, is I'll highlight this function, is we take our original function and replace x with c. So that's how we get -c squared minus 8c minus 17 is equal to our average value, -2. I feel compelled at this point to bring up that this value c is not necessarily the same as the constant of integration, which we talked about earlier with indefinite integrals. We're using c here because it's in between the range of a and b. Anyway, getting back to the problem, through the wonders of algebra, we have a quadratic. We factor, set it equal to 0, and we find out that our two values of c are at -5 and -3.